So let us say this is one vector and this is another vector, and we want to add these two vectors. So we will call this as A bar, we will call this as B bar. Don't write anything simultaneously, just keep listening, and towards the end I'll give you time to write it and then you can, okay? The angle between the two vectors is theta. Now the parallelogram law of addition of vectors requires us to draw a line parallel to A, but touching the tip of B here, like this. Right, let me decrease the length a little bit. I don't think we'll be needing so much of a length. This should be. Now we need to draw a line parallel to B, but that line should be starting from the tip of A. Let me bring this from the tip of A. Now, wherever these two lines intersect, the two parallel lines that we have drawn, from the point of starting of these vectors to the point where these two parallel lines have met, we draw a diagonal, and this diagonal of the parallelogram represents the resultant both in magnitude and in direction. Is it clear up to this point? We have to draw a line parallel to A, we have to draw a line parallel to B. The line being drawn from parallel to A should be drawn from the tip of B. The line being drawn parallel to B should be drawn from the tip of A. Wherever these two lines meet, from the starting point of both the vectors to the point of intersection, that diagonal will give us the resultant of these two vectors. Because there is another diagonal possible like this, that does not give the resultant, right? Only the first diagonal gives the result. I hope that is clear. Yes. Okay. Now, in order to obtain a mathematical expression for that, we'll need to do a little bit of construction. So we will extend this line forward. We will extend A forward. Whatever extensions we do, that should be with dotted lines. In fact, these two parallel lines that we have drawn should also be with the dotted lines. But drawing a dotted line exactly parallel to B would not be possible. Therefore, I just took a straight line tool with a different color and I finished it. Otherwise, in your notebooks, even this gray colored line should be with dotted lines. Then we drop a perpendicular like this, right? Wait, let me just draw this once again. We draw a perpendicular from this. Right. So this angle is 90 degrees. And now let us name them. This is a small a, small b, and a small c, small d. This extended part, let us call this as E. Okay. If this angle between A and B is theta, naturally this angle between these two lines should also be theta. That is easy to understand. It is just that vector A has been extended and DC is just parallel to AB. So it is obtained the same. Okay. Then, now let us consider triangle ACD. Oh, sorry, ACE. Let us consider triangle ACE. Does that look like some special kind of a triangle? Triangle ACE. It is a right angle triangle, isn't it? Yes. So if it is a right angle triangle, then we can use Pythagoras theorem. So AC square is equal to AE square plus CE square. But from this diagram, it is clear that AE can be written as AD plus DE. So AC square can be written as, in brackets, AD plus DE, and then square plus CE square. Now, once we expand this, you will get AD square plus DE square plus 2AD DE, and then the last term, CE square. Now, one has to be careful as to what we have written. 2 times AD and DE. The reason why I'm telling you is, telling you this in such a detail is, you people sometimes don't have an idea as to what we teachers go through. There have been instances where I derive this on the board in the regular contact classes here in India. I derive this on the board, The students write this down, and after 1 week, during that weekend exam or some unit test, they come running back to us. They'll say that, sir, we have understood everything. What we did not understand is, what does this a day mean? They don't even realize that it is not a day. It is ADDE. Therefore, I'm taking all the trouble to write it as AD space DE. A little bit of space is there. Okay. Now, today my digital pen is giving a bit of a problem, some update issue or something. See, even when I move it in air, it is drawing some random lines. So I have to put up with that. So let us call this as, okay, this was CE square. Let us call this as equation 1 and leave it here. Now, let us consider this triangle CDE. In triangle CDE, which is also a right angle triangle, can you define sine theta? Sine theta from this triangle is that is CE. That is DC. So I can also write it as CE by, isn't DC of the same length as that of B? Right? So we will write B here. Therefore, from this we get CE is equal to magnitude of B, it means only the length, into sine theta. Call this as equation 2. Similarly, let us write down cos theta. Cos theta is adjacent side DE by hypotenuse, the same thing, P. Therefore, DE can be written as magnitude of P into cos theta. And let us call this equation as equation 3. Now, in this equation 1, you see there is a DE here, there is a DE here, there is a CE here. We can make all those substitutions now. Therefore, what is the length A to C equal to? Isn't that just the magnitude of R? A to C. So we will just write R square. Now, strictly speaking, wherever there is a magnitude, we should be using this symbol. But once we understand that, yes, we should be using the symbol, you can also use it only once in the exam. In your class notes, you can just write it like this. If you want to be very specific and orthodox and methodological, then of course you can put a bar here like this. Presently, we'll just write it as R is equal to AD square. What shall I write in place of AD square? From the diagram, AD square. Just the magnitude of A, isn't it? Is it very difficult? Right. Yeah. So this is magnitude of A square. Then there is a DE square. DE from equation 3 is your B cos theta. So when you're squaring it, B square cos square theta. Then what else is left after that? 2 times AD, that is A, and then DE, that is B cos theta, plus the last term is CE square, that is B sine theta. But since it is a square, we'll put a square. So now we get R square is equal to A square, B square cos square theta plus B square sine square theta. How much will that be? Did you do that much amount of mathematics in 10th class? Sine square theta plus cos square theta is equal to 1. So left is only B square. A square plus B square, because sine square theta plus cos square theta is 1. And what is left is the third, 2 times A, B, cos theta. But this is not the answer, because this is square of the resultant. We never wanted square of the resultant. We wanted only the resultant. Therefore, R is equal to root of A square plus B square plus 2AB cos theta. This was the formula that we were using in yesterday's class and in day before yesterday's class.
Sir, can you explain to AB cos theta that what?
To AB cos theta. I have just written whatever was here, the same thing here. That's it.
No. From like how did 2AD EE change to AB cos theta?
Acha. Okay, right. I'll do that. Control Z. Okay. This pen is going to kill me today. Oh God. Showing all sort. The moment I bring it near the digital pen, it is showing all those lines. I don't know. Sometimes it happens like that. Just a second. Let me roughen it up a little bit. Sometimes it works like that. No, it's still giving some problem. I'm not able to even bring it close to the digital pad. My God, what has happened to it? Let me just disconnect. Okay. So, did you understand why CE is equal to B sine theta? Is that clear?
Yes, sir.
Okay. Similarly, DE is equal to B cos theta. That is also clear.
Yes.
Okay. Now, AD, this distance from A to D, isn't this distance same as this A, vector A?
Yes, sir.
But only the length, right?
Okay.
Therefore, instead of AD square, we have used A square.
Okay.
Okay. Similarly, DE square. What is DE equal to? We found out from equation 3 that DE can be written as B cos theta. So if DE can be written as B cos theta, then DE square can be written as B square cos square theta.
Yes, sir.
Then 2 times. This 2 is here itself. AD. AD is capital A, and DE. This DE is equal to, from equation 3, that is equal to B cos theta.
Okay.
Similarly, the last term, CE square, that is equal to B square. Got it now?
Yes, sir.
And did you understand the last but one step? Why did this only B square come here? Because B square cos square theta plus B square sin square theta. Sin square theta plus cos square theta is 1.
Yes, sir.
Okay, write down up to this first, all of you, including the diagram. And don't be too liberal with the diagrams. I have seen students drawing parallelogram law of addition of vectors diagram like this, and then they will draw 2 parallel lines, and then they will extend this and then say a perpendicular is dropped. Now, does this even look like a perpendicular? So drawing those kind of diagrams is very dangerous. Take the trouble of taking out a scale, let the parallelogram look like a parallelogram. If you are very good at freehand drawing, then it's okay. Otherwise, science students should have certain characteristics. Always be liberal with your pencil, scale, eraser, protractor. That is a hallmark of a science student, right? Otherwise, why would a science student move around with a tabla or a sarangi? They won't be moving around with that, right? And once you finish writing, let me know.
So how did 2AB cos theta change to 2AB in the end?
It did not get changed to. In fact, I was having a trouble with my pen. So in using Control Z, Control Z, Control Z, that cos theta got lost here. It is cos theta, of course. It was drawing those random meaningless lines. I was trying to undo that, and cos theta also got knocked off.
So I had my science exam today, sir, and I have a doubt in physics. So can I ask a question? Yes, sir. So it was related to concave mirror actually. Yeah, mirror formula. So the question, it is an assertion reasoning MCQ question. So the assertion given is mirror formula can be applied to a plane mirror, and the reason is that a plane mirror is a spherical mirror of an infinite focal length.
Yeah.
So both of them are correct.
Yeah,
statements.
correct.
Yes, sir. So while we apply mirror formula to a plane mirror, it will be 1 by f is equal to 1 by v plus 1 by u. So it will be 1 by infinity is equal to 1 by v plus 1 by u.
Absolutely correct.
So 1 by infinity is equal to 0.
0.
Okay, sir.
And that in fact gives you directly the answer. 1 by infinity, which is 0, is equal to 1 by v plus 1 by u. Now bring it to the other side. Therefore, 1 by v is equal to minus of 1 by u. Therefore, v is equal to minus of u. Doesn't this exactly prove that object distance is equal to image distance in a plane mirror?
Yes, sir.
That's it.
So
And
but
minus means if the object is towards the left hand side, image will be towards the minus of that. It means towards the right hand side. Therefore, it's a virtual image behind the mirror.
But when we take 1 by infinity is equal to 0 and then we take reciprocal of each side, then infinity is equal to 1 by 0.
No, I have just solved this one first, the left hand side, and I have left the right hand side as it is. See, suppose if I have 1 by 2, can I not write it as 0.5?
Yes, sir.
Does this require me to change the right hand side? No, right? I can just write 1 by 4 as 0.25. I can write 1 by 2 as 0.5. That is what I have done first. That's it.
So, but to prove it, when we take 2 to the other side, then it's 1 is equal to 1. So that is justifiable. But when we take here infinity to the other side, then 1 is equal to 0 into infinity.
Infinities cannot be taken to the other side, right? So if there are anything to do with infinity, we solve that first and then come to the other. Infinity is not just like any number where you cross multiply and take it to the other side. Right? Infinity, another meaning for that is undefined. Can you multiply any numerator or denominator with an undefined quantity?
No, sir.
No, right? There has to be some defined quantity, well-defined parameter. That is the reason. So all of you have written this? No. Yeah. Okay, while others are writing this, let me ask another question. Our job was to find out the resultant vector using parallelogram law of addition of vectors, isn't it? So if that was the task, do you think the job is done after we get this last equation, equation 4? Do you think our task is complete? Think carefully. What are the two qualities that a vector has? One is a magnitude and one is a direction. What did we manage to find till now?
Magnitude.
So there is still a little bit of a job left. We have to still find out the direction. And how do we find out the direction? The direction is defined by the angle made by the resultant vector with respect to the first vector, and this is called as alpha. So how do we find out alpha? Here, certain important things have to be understood before we proceed. So let me just wait for everyone to stop writing. After they have finished writing, then we'll continue. Everyone has finished writing, or is there any? Acha, Ayush is still writing. Okay, carry on. Abdul has finished writing, Sidra has finished writing, and I'm just guessing, right? Right. Rihan finished writing. Yeah, okay. Nevin finished writing. So we'll just wait for Ayush. Prithviraj has also finished writing. Okay, right. Ayush is also done.
Yes,
Right.
I'll be able to.
Then, using trigonometry, there are three kinds of ratios that we speak of basically. One is a sine theta, one is a cos theta, one is a tan theta. And since we have an alpha here, we can write alpha in terms of sine alpha or cos alpha or tan alpha. In textbooks, you will see it would be given that considering triangle ACE, we take tan alpha is equal to, and they start off from there. But the big question is, why only tan alpha? Why not sine alpha? Why not cos alpha? Because these are certain simple but subtly important things that if you understand, your understanding of physics later on will become very easy. Easy and complete also. Okay? Did you understand the issue here? I'm telling you that the answer is obtained, the direction is obtained by using tan alpha. But I also want you to understand why not sine alpha, why not cos, because they are also trigonometric ratios. So I think you can get the answer from that also. Why don't we take it? The reason is because if I take sine alpha is opposite side CE. CE is okay. I know the value of CE by hypotenuse. Sine alpha is opposite side by hypotenuse. Hypotenuse is something that we found out now. Was it already given to us beforehand? No, right? So how is it useful in defining an angle in terms of a quantity that was not given to us? That is unfair. Similarly, if I take cos alpha is adjacent side AE, that is okay, but divided by, again, the same hypotenuse. Hypotenuse is something that we calculated now. It was not given to us earlier. Earlier, we knew only three things. What was those three things? A, B, and theta. R was not known to us earlier. So whatever final answer we try to find out, that should be without using R. So sine alpha is out of question. Cos alpha is out of question. Now what is the only angle left now? Tan alpha. Therefore, we start with tan alpha. In textbooks, all these details cannot be given because otherwise already physics books are very cute 500 pages books. If you start writing these kind of details, it will be 1,000 pages. You know what happens if physics book becomes a 1,000 pages book? Half of the students will stop studying physics. Right? They'll just look at the book and they'll pick up some other subject. Therefore, these kind of details, too much of a details cannot be given in the books. Right? Not because they don't know it. Everyone knows it. But too much of detail cannot be given in the books. We also don't write it in our notes that sine theta cannot be taken so and so, cos theta cannot be taken so and all that. We just understand that and therefore we say tan alpha. Tan alpha is opposite side CE by adjacent side, that is AE, which can also be written as CE by AD plus DE. Now can you complete this? Tan alpha is CE, that is B sine theta, by AD plus DE, A plus B cos theta. Is this the answer? Think about that carefully. We wanted magnitude and direction. It means magnitude and angle. Is this the final answer? Actually, no. Because equation 5, does it give you the value of alpha or does it give you the value of tan alpha? It gives us tan alpha, right? But we don't want tan alpha, we want only alpha. So one way of writing alpha from this is, I'm writing this in the box here because, otherwise I'll have to go to a new slide now. Therefore, alpha is tan inverse of, and write down this entire expression, B sine theta by A plus B cos theta. Now it is complete. Equation 4 gives us the magnitude and equation 6 gives us the direction. Now we have managed to find out both the magnitude and direction. Is it clear now?
Can't we just write cot? No?
Alpha is tan inverse of B sine theta by A plus B cos theta does not mean 1 by tan alpha. Tan alpha is different, 1 by tan alpha is different. I'll tell you that distinction. See, I'll use another color here so that you don't get confused with what is already written here. Suppose I say sine 30 is equal to 1 by 2. We know this, right? Then how much is 1 by sine 30 equal to?
2.
If invert this, I have to invert this also. This is 2. This is clear. I think everyone has understood this.
Yes.
But this is not what is used here. What is used here is, if sine 30 is 1 by 2, then 30 degrees is sine inverse of 1 by 2. Isn't it conveying a totally different meaning than what I wrote earlier? 1 by sine theta is different from sine inverse. Sine 30 is 1 by 2. If you write it like this, it means 30 is the angle for which, if sine is calculated, then its value will be 1 by 2. That is the meaning of it. Is that same as 1 by sine? No, right? Because 1 by sine theta was 2. That is a totally different thing. This comes under a mathematical heading called inverse trigonometric functions. You will be learning that later on in 11th class. There will be a full chapter on it, right? So if entire sine is being brought down, 1 by sine theta, then you should not write it as sine inverse of something. Then what you do is, you will say sine theta, put everything in brackets and write minus. This is not same as sine inverse of only the brackets. That is different. Okay? At least remember that distinction and that will be fine. Mathematically, that is the thing. From your point of view, I'll tell you how to understand this. Suppose you solve everything and you will get alpha is equal to 1 by root 3. Can you figure out what will be the value of tan from this? Or suppose tan alpha is 1 by root 3. Then alpha will be equal to
30.
30, right? How did you say? Because you already knew that tan 30 is 1 by root 3. Writing this actually means, okay, go back to your table, see for what angle is the answer 1 by root 3, and therefore that angle is the answer. That entire English statement is written in a mathematical form like this. That's it. Remember in the first class, I told you people, mathematics is the language of physics. Writing it in this form of equation 6 means look out for the value of angle for which the right hand side should give you this value. That is the meaning of this. Okay. So we have seen addition of two vectors. Similarly, let us proceed to subtraction of two vectors. Shall I clear off the screen now? Okay.
Can you explain the why we don't use sine and cos again?
Because sine theta requires opposite side CE by hypotenuse. Hypotenuse is R. Suppose we had not done all this derivation, for example, then we wouldn't be knowing the value of R. So can we use sine theta where the input itself requires R? Oh, sorry, not sine theta. This one is alpha, sine. In order to calculate alpha, if I use CE by R, CE is okay, but how do I know the value of R? That was not given to me. So is it convenient to write it in terms of a quantity that we have calculated or that is not given to us beforehand?
So like
No.
if in a question we have to find R either way,
Then it is okay.
then it's okay,
If
right?
in a question, yes. Because when you're solving a problem, if you have found out R, you have all the liberty to use it. But when you're developing a theory, the theory should be developed only on the basis of what are the known quantities. Magnitude of A is known, magnitude of B is known, and theta is known. So everything that we try to derive should be only in terms of that. But while solving problems, you can take liberty with that. Once you have calculated R, you have absolute freedom to use it wherever and whenever required.
Okay.
Okay? Right. And any other doubts, others? Shall we proceed to subtract two vectors? We have done addition of vectors for so long. Now let us proceed to subtract two vectors. Now, again, the same process. In my classes, the approach should always be the same. When I am explaining, don't get busy writing it. Of course, I can't arrest you for writing it. But then when I'm explaining something, if you get busy writing, it tells me that you're a very sincere student. But you know what will be the end result of that? Your notebook will be full. This one will remain a bit empty. And I'm not a teacher who's going to rush through things. I'll not assume that students have written everything simultaneously. Therefore, I erase and go to the next one. Even if you think I have erased it, I can use Ctrl Z and it is still there on the screen. Right? After I say that, okay, so let us proceed and you continue like this. Then you say, sir, I didn't write the last equation. I'll say, okay, write this. I can do that. Right? Or I can lead you to a source where those last few steps will be there and you can go. Whichever way, I'll give you time to. Now, let us look at subtraction of vectors. Subtraction of vectors. For subtraction of vectors, we will very innocently, let us say pretend. Yeah, we will very innocently pretend as if we know only addition of vectors. And there's nothing wrong in it. That is what we have done till now. Did we actually do subtraction till now? No, right? We know only addition of vectors. So suppose you have to subtract one vector from the other. Suppose you have to do A minus B. We can also write it as A plus of minus B. So what is it that I have to do? I have to basically do only addition. But add what? Add negative of B to A. So that can be done. Let us see that. Suppose this is one vector A and this is one vector B. This is vector B and this is vector A. If you complete the parallelogram here itself like this, then the resultant that you get, will it be A minus B? Will this resultant be A minus B? No chance, right? That is A plus B. So what is it that you have to do first? Even before you start doing the parallelograms and all that, you have to draw a vector that is exactly opposite to B, like this. Now this vector is exactly negative of B. We have learned this yesterday. What is negative of a vector? A vector of the same magnitude but exactly opposite direction. Now what is this angle? This angle is theta. Total angle in a straight line is 180. So how much will this angle be? 180
minus theta.
Now go about doing the same thing. Draw a parallel to this line. Draw a parallel to this line, that is A, right? And wherever these two parallel lines meet, draw a resultant from that common point. This resultant. Now this resultant, I will call, I can't call it as R. Okay, fine. I'll still call it as, okay, let us call it as S for subtraction. This resultant S bar is addition of A to the negative of B. Therefore, it is as good as saying A bar minus B. Now, this also can be proved using dropping a perpendicular, considering the triangle ACE and all that can be done. But without that also, let us see how to do this. Just like we had R is equal to root of A square plus B square plus 2AB cos theta. We had this for R. Don't write anything now. Likewise, for S, what should we do? We are still adding. So A square, negative of B, when you square it, that will still be B square only, because negative and negative will be gone. So that will be B square plus 2A. Here you should not put minus B, because when we were writing, we only took the magnitude. We took the length of that side in the triangle, right? Why will the length be negative? Length will just be 2 centimeters. Whether you draw it in this side or this side, it will still be 2 centimeters. Therefore, this one will continue to remain B. Now cos of, now think about it carefully from the diagram. What theta did I include earlier? The theta was between A and B because I was trying to add A and B. What theta should I take now?
180.
A and minus B, because those are the two vectors that I'm adding. Therefore, 180 minus theta. Cos 180 minus theta is minus cos theta. Right? Now, don't ask me why. Of course, it can be understood, but that is for mathematics teachers to deal with. And you have an entire chapter on that. Trigonometry, sin 90 minus theta, sin 90 plus theta, cos 180 minus theta, cos 180 plus theta. You might have done that in 10th class also, remember? All, silver, tea, cups. Was this done? Not yet. I already see lots of confused faces.
We don't delete it first, that portion.
And in 11th class, your teachers will start with that. When they do trigonometry, first they'll tell you about angles and all that. As for now, you have faith in me, I'll have faith in the math teachers. Saying that what they say is correct, therefore we'll say 180 minus theta is minus cos theta. But there are proofs for that. Your math teachers will tell you. If that chapter is done and your school teachers don't do that, then let me know. I will take up that. I'll take an entire class on how to convert from one angle to another angle and all that, but not now. So root of A square as it is, B square as it is, cos 180 minus theta is minus cos theta, therefore minus 2AB cos theta. This is the resultant of subtraction of two vectors. But this is not the complete story, because this gives only the magnitude. There is still a direction to be found out. Therefore, direction is given by alpha dash, or let us write tan alpha or directly alpha. Alpha dash is equal to tan inverse of B sine, again it should be 180 minus theta, but sine 180 minus theta is sine theta itself, divided by A plus B. Cos 180 minus theta is minus cos theta. Therefore, here itself we will write minus B cos theta. So here I have used two properties. Sine 180 minus theta is sine theta. Cos 180 minus theta is minus cos theta. Why and all that, we can see that later. Okay, done. Now copy down. This is under the heading of subtraction of vectors. Done. Finished writing, everyone? Abdul finished? Yeah. And Prithviraj?
Yes, sir.
Right. Sidra? Acha, 1 minute. Okay. Rehan?
Yes, sir.
Finished? Yeah, you can just nod your head because I can see all of you. So that will be fine. Nevin? Finished. Ayush is still writing. Sidra is finished now. Right. Ayush is also done. Now, let us take up a numerical directly to...
I have a doubt, sir.
Yeah.
So here, which angle is going to be considered as alpha?
Alpha. Alpha is always defined as the angle between the first vector A and the result. Alpha dash. This.
Okay, sir.
Okay. Then, let us take up an example that will help us use both addition and subtraction of vectors. Question is, if magnitude of addition of two vectors is found to be equal to the magnitude of subtraction of the two vectors, then find the angle between the two vectors. Suppose that is the question. It means there are two vectors, and very strangely, when you add them, you get the same resultant as you get when you subtract. If that is the case, then find the theta. In such cases, what you have to do is directly use the condition given. How do you find out magnitude of resultant of addition of two vectors? Root of a square plus b square plus 2ab cos theta. And how do you find out the magnitude of subtraction of two vectors? Root of a square plus b square minus 2ab cos theta. So when you square both the sides, you will get a square plus b square plus 2ab cos theta is equal to a square plus b square minus 2ab cos theta. A square, b square. A square, b square get knocked off. So 4ab cos theta turns out to be equal to 0 because then there'll be nothing left on the right hand side. If I bring that minus 2ab cos theta also to the left hand side, isn't it? So this implies that cos theta should be equal to 0. What is the angle of theta for which cos theta is 0? 90. Therefore, we say theta is equal to 90 degrees or pi by 2 radians. If you want to write it in terms of radian, then pi by 2. If you want to write it in terms of degrees, then 90. Degrees is one unit for measuring the angle. Radians is the other unit. In fact, radian is the SI unit. Write down this example.
Can you explain the 4ab cos theta to cos theta?
All that I have done is I have retained 2ab cos theta as it is, This minus 2ab cos theta also I have brought it to the left hand side. Minus, once you bring it to the left hand side, it becomes plus. There is already a 2ab cos theta, another 2ab cos theta comes here, therefore 4ab cos theta. That is equal to 0. Now, there are two ways of proceeding to the next step from here. You can say that if this entire product is 0, 4 cannot be 0, A cannot be 0, B cannot be 0. Because if either A or B is 0, then there is nothing to solve here. Therefore, it means only cos theta can be equal to 0. Therefore, theta can be 90. That is one way of doing it. Or in the next step, assume that you are bringing this 4 here down. 0 by 4ab. That is also 0. In a fraction, if the numerator is 0, then the value of fraction is 0. That is another way of understanding. Okay. Finished? Shall we go to the next one? So what have we done till now? We have seen that vectors are certain important quantities which have magnitude, which have direction, and which follow vector laws of addition. Unless this is also satisfied, you should not say that they are vector quantities. And what are the vector laws of addition? The triangle law, the polygon law, the parallelogram law, these laws. When do you use triangle law? When there are two vectors. When do you use polygon law? When there are more than two vectors. When do you use parallelogram law? Again, when there are two vectors. We have also seen yesterday that whether you use triangle law or whether you use parallelogram law, the resultant will be the same. So you are at liberty to use any one. Then we also realized that always drawing a triangle, always drawing a parallelogram, all that was a big headache. Therefore, what we developed was algebraic solution. And in the algebraic solution, we got the value of resultant in terms of A, B, and theta. That is what we have done. But there is a little bit more to be done. That is because if you have only two vectors, then this algebraic solution will work. What happens if there are three vectors, 4 vectors, 5 vectors? Then isn't that going to be a very difficult task? Add 2 vectors, get the resultant magnitude and direction, then see what angle it makes with the third vector, again get magnitude and resultant, then bring the 4th vector into picture, again get magnitude and resultant. That is going to be one hell of a task, right? It is best possible, if it can be avoided, you avoid such kind of calculations. Then there should be some alternate method to solve it. That method requires what is called as resolution of vectors. But resolution of vectors is a little bit more intricate concept. I will not touch upon that now. I'm just telling you that what is there in future for us. We have to also understand what is called as resolution of vectors. But before getting into resolution of vectors, let us come back to something that I've told you yesterday. If you want to indicate a direction in the right hand side, in vector notation, how will you indicate that direction? Yesterday I told you. I with a topi on it.
Oh, yeah.
I cap, because it's a special vector. It tells you only about the direction. If you want to indicate the left hand side direction, minus of I cap. It means exactly opposite of the right hand side direction. If you want to indicate something going upwards, J cap. Something going downwards, minus J cap. Right? Something coming towards you. It means from the screen like an arrow coming out. Then that is K cap. Something going into the screen, minus K cap. Now, using only these things, let us see how they can be used in physics. I cap, minus I cap and all that. Let us see how they can be used in physics. Are you familiar with these equations? V is equal to U plus AT. S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. Are you familiar with these equations?
Yes, sir.
Can you tell me what is U here?
Initial.
Initial velocity.
Initial. What does initial mean?
Beginning
Beginning of?
the movement in this.
Beginning of the movement. But any movement will start from rest. What is initial velocity of any train or any flight that you have come across in life? Even when aeroplanes start, they have to start from zero, right? And trains, zero. Buses, zero. And we should be very thankful for that. Otherwise, if the planes don't start from zero, imagine passengers running behind the train to catch the train, right? So thankfully, initial velocity is zero. Then what about final velocity? We should be doubly thankful that the final velocity is also zero. Otherwise, imagine an announcement being made that passengers, please pay attention. Hyderabad station has arrived and be ready to jump off the train. Are there any announcements made like that? No, right? So the final velocity of a train is zero. Final velocity of a bus is zero. Final velocity of an aeroplane is also zero, thankfully. Otherwise, in case of buses, you only have to jump onto the road. In case of planes, you are jumping off from the sky, right? Thankfully, those kind of things don't happen. So if that is the case, then what is the point in even writing this equation? Initial is always zero, final is always zero. So AT is equal to zero, A is zero, T is zero, then there is nothing to solve, isn't it? So my question remains, if you say initial, what is meant by initial velocity? And if you say final, what is meant by final?
Initial
Understand?
in a certain time period.
In a certain, almost correct, but don't add the word period. In a certain interval of time. That's time period is a very specific term that is to be used only when the body is continuously repeating its motion like this, like a simple pendulum. Then the time interval within which that motion is repeated once, that is called as time period. Okay? That is why, I mean, you'll curse me for taking this example, but that is why in your schools, they'll say, what is the first period? First period is science. Second period is math. You know, why do they say that? Because Monday, Tuesday, Wednesday, Thursday, it's the same timetable. It keeps repeating itself. Every week, it's the same thing. Monday morning, third period is physics, or fourth period is chemistry. That is the reason why period is used there also. Right? But otherwise, don't use time period, time interval. So, initial and final, the two terms that we use here, you must understand that they are contextual. Contextual means that they have to be understood in the right context. I'll give you one example. Suppose there is a railway track and there is a person standing next to the railway track. Next to the railway track, not on the railway track. On the railway track is a very dangerous thing. I don't advise anyone to stand on the railway track. Right? Next to the railway track, there is a person standing and he has taken a white powder, the one that we use for marking in a cricket match or in a kabaddi game or whatever, and he marks something here. And he has marked something here also. He calls this point as A. He calls this point as B. He takes a stopwatch and he's ready. He's waiting. And a train comes from left-hand side. The moment the train touches this mark A, he starts the stopwatch. And the moment the train leaves point B, he stops the stopwatch. So is he worried about where the train has started? No. Is he worried about where the train is going to go? Whether it is late or whether it is on time, he is not bothered about all this. He is watching the train only from A to B. So where his experiment begins, the velocity of the train at that instant of beginning the experiment is called initial velocity, and the velocity of the train when he completes his experiment, that is final velocity. That's it. So is that really the initial and final velocity of the train as a whole? Whether it started at Delhi, whether it is ending in Chennai or somewhere, why should he worry about that? He has marked 2 points A and B, and his experiment is to deal with only those 2 points. That is why I say initial and final, the words are contextual. If an astrophysics person thinks about what is the initial time or initial position, probably he's speaking of beginning of the world because he's an astrophysics fellow, right? If an atomic physics fellow says, what is the initial velocity? Probably he is speaking of velocity of an atom at a particular instant of time. In a cricket match, if they say, what is the initial over or how many runs are scored in the first over? Now, does it mean first over means the first time ever the cricket match was played in the world? No, right? They speak of only today's match, which started at 7:30. How much runs are scored in the first over? So the first over, isn't that understood in that context? Last over does not mean that from tomorrow onwards, no one is going to play cricket. Last over means in today's match, what is the last? But no one says all that. They just say last over. They just say first over. Like that, even in physics, initial and final velocity means initial when the experiment started, final when the experiment ended. That's it. Is that clear? Because these kind of things are very basic. It is from here that we start applying vectors and all that. Then, furthermore, because there are only just about 3 minutes left, instead of applying vectors to that, I'll tell you one more thing. If someone says, what does equation 1 give you? What will your answer be? In a very specific scientific terminology. What does equation 1 give you? Shall I tell you what the answer should be? Equation 1 gives us, you should start the sentence by saying equation 1 gives us, what is there on the left hand side?
Final velocity.
Final velocity. Then on the right hand side, initial velocity is decided at the beginning of the experiment itself, right? Is that going to change once the experiment has started? It's not going to change. So this is a constant. This equation is applicable only in the situation where acceleration is constant. So what is the only parameter that can change now? Time. Therefore, if anyone says, what does this equation give you? You should say equation 1 gives us velocity as a function of time. This is how you should quote your answer. What it means is that equation 1 tells us what will be the velocity of the body at any instant of time. You put t is equal to 10 seconds, you'll get to know what was the velocity of the body at 10 seconds. You put t is equal to 20, you'll come to know what was the velocity of the body at t is equal to 20. So isn't it helping us calculate velocity for any given time? A mathematical way of stating that is that this equation gives us velocity as a function of time. Like that, can you tell me what does the second equation give us? Second equation gives us displacement as a function of
time.
But there is a t square also. Moral of the story is, if time is a variable, whether it appears as a square or cube root or square root, whatever be the case, you don't mention all that. What is the variable? Time. How is it varying? Is it varying as a square and all that? Don't bother. So what does equation 2 give us? Displacement as a function of time. That's it. Likewise, what does equation 3 give us? Whatever equation 3 gives us, you can't come to that conclusion directly by looking at this. First of all, isolate this on the left hand side. V square is equal to u square plus 2as. Now forget about square and all that. What is this term here? Velocity. Equation 3 gives us velocity as a function of, this is constant, this is constant, this is constant. It gives us velocity as a function of displacement. Is it clear up to this point?
Yes, sir.
Tomorrow, we will take up various cases of these 3 equations and combination of that with whatever little we have learned about vectors. That will be the task for tomorrow. Okay? That's all for today. Have a nice day.